let's take a little time to provide another overview of indexing in Excel. So here's just a reminder of one of the great ways that Excel can help you, in particular when you need to do some calculation on a long list of data points. Excel can help you do this quite efficiently. So the one that we went over before is basal area. And let's just do that real quick to kind of give you a reminder how this works. I've got our class data from Poly Canyon here, and I'm going to write in a new column heading here, basal area. Of course, because diameters are in centimeters, I'm going to calculate this in square meters. Now, if you recall, the way that the way to do this efficiently is to write in a little equation here, and basal area is, you've measured diameters, and we're going to convert that into area. You can do that with the pi r squared equation, but something equivalent and easier to write in Excel is this, this little linear transformation. And that's, we take the square of the diameter by selecting the cell that we want to make this calculation from, and then using this little tilde character, and then I'm going to type in the number 2 because it's telling it that we're going to square that parameter. And then we have to multiply by this linear parameter, which is 0.000, it's 4 zeros, 7854. And again, what this is doing is it's avoiding this slightly more complicated way of writing this in Excel with pi r squared. But they are equivalent. You can go through and do the calculation. You can show that pretty easily. Okay, so I hit enter, and it calculates basal area. And I think something is wrong here because basal area of 12 doesn't make any sense. Always look at your data to ensure that what you've calculated is sensible. The 12 square meters is a big area, and I know that although a 100 centimeter tree is pretty big, it's not 12 square meters of surface area if I was to cut that down at dBH. So what I can do here is hit F2. You can see where my mistake is. Obviously I've written one in here, and it looks like I've forgotten a 0. So I add that and hit enter, and then the updated calculation is 1.2 square meters, more or less. And that's pretty, that seems on. You know, a 100 centimeter tree is a pretty big tree. That's about a square meter. Okay, so one of the things that Excel does well is do a bunch of the same calculations for you. You know, back in the days when they only had calculators, you know, foresters and a lot of other fields where you have to do a lot of calculations, you would just be going through and doing this over and over and over again on the calculator, and it would be extremely tedious. But the good news is we have more efficiencies now, and one of the things that you can do is you can just copy this equation, and we're going to copy it in a way such that it updates for the part of the equation which varies, and that's the diameter of each individual tree. Now when you hover the cursor over this little box here, you see there's a little kind of bolded box on the end, and you can just drag the equation and it will copy, and you can see that it's copying and calculating basal area every time. You can go into these individual cells, and you can ensure that it's calculating correctly. Be careful, always hit escape if you do that. F2 gets you in, function 2 key, and then escape gets you out, and you can see that this is calculating correctly. It's doing what I expect it to do. Another trick with this little square is you can just double click on it, and what that did was it copied the equation all the way down to the end of this thing, so I don't have to write it again and again and again. Beware, I just had to update Excel because as I was trying to demonstrate this, it had some weird error where it was giving me a repeated number over and over and over. I don't know what the problem was. It was in the middle of an update, and I updated Excel, and that error went away. Here, let me give you another example of something that you can do here. Oh, excuse me. something that you can do efficiently using Excel. Let's another common calculation, one that's pretty useful, is to do a calculation of biomass. Now, one of the problems with biomass is the equations vary by species. So what I'm going to have to do here is actually sort this. I've got a few problems here. I've got some groups that haven't updated their species, and I'm not going to be able to calculate for those things, but I'm going to ignore it for now in order to simply demonstrate this. But one of the things that I have to do to make this efficient is to get everything ordered in terms of species if the equation is going to vary in that way. So I'm going to sort this entire data set, and the key thing, sorting a data set can really screw it up if you don't have everything highlighted. And one of the things I'm going to do is just make sure that I've got everything selected here so I don't lose any data. And I checked it. Now I'm going to go back. I'm going to sort by. If you've selected the columns, you can sort by whatever you want to do. And the thing I recommend you do is sort by species if you're trying to do biomass. And here's why. I'm going to write in a new column, biomass. And I've got eucalyptus here. I'm going to use the general equation for hardwoods. All right. You might choose to do something more specific. That's fine. I'm just going to write in the general equation for hardwoods. So this is equals the exponent of this linearized equation, and I'm going to do mixed hardwoods. So that gives me an intercept of minus 2.4800. And what I need to do here is add that to the slope of this equation modified by the diameter. Okay, so what is that? It's 2.4835 times, and the natural log. I use a lot of parentheses when I write in Excel, and the reason for that is because I don't trust it to understand order of operations. Sometimes it does some weird stuff. So I put everything into parentheses, even if they're not necessary. And then the last thing here is we're taking the natural log of the diameter, and then I have to close all the parentheses, and I do that. And I've got some error. I forgot one of the parentheses, and it says, do you want to add one? And I say yes. Okay, and so then I've got the biomass of the tree in kilograms. 1,400 kilograms. Seems about right. 1 megagram of carbon or biomass in this tree. It's a big tree. That seems right to me. And so again, I'm just going to copy this equation. And one of the things I'm going to do is just kind of scroll down and make sure that there's nothing in here that says it has an error. At this point, I've actually used the general hardwood equation for everything here, which may not be what you decide to do. And what you can do is just kind of scroll down here, and you can update as you think are necessary. So for example, if you had some hardwoods, or excuse me, if you had some conifers, and you needed a different equation here, or if you just felt that it would be more accurate to use one equation over another, and you would oftentimes be justified in doing that. Many of these trees, especially bay laurel, just has lower biomass density. Okay, so that's pretty nice. I've calculated basal area, I've calculated biomass, and I'm going to do one more thing. I would like to know how I would like to categorize these stems into different groups of sizes. And there's a way to do that that requires a kind of annoying process, but annoying equation to write. But once you have it, it's really useful. And I'm going to do, write in a column here, size class. All right. Size class is going to be a kind of index variable. I'm going to create a new index variable. And the kind of index variables that you're accustomed to are things like plot, species, some way that you can divide your data such that you can do other kinds of analyses with it. And I'm going to do that here, but I'm going to create I'm going to create size classes for our data set, our different categories. Okay, and so here's how this works. You got to end up writing a long equation. You need to write a series of logical statements, and the way you do this is you write a series of nested logical statements that will give you an index that says what relative size class does this each of these individuals belong to. Okay, so I'm going to start with the simplest. So we're going to use the equal sign, of course, writing an equation. And this logical statement is an if statement. So I write if, and the logic, what happens is once you write that and hit the parentheses, you get this kind of dialogue that helps you write this equation correctly. What's going to happen is I'm going to write some logical test. I'm going to ask the data if it meets some condition. And if it does, it's going to get some true value. And if it's false, it's going to get some other value. Now, the other value, if it's false, can actually be an if statement. And that's where the nesting happens. We're going to create a series of nested if statements here. So, but I want to start with what's the simplest. So all of this is, we're doing size class, so it's going to be based on the diameter. What I'm going to do here is I'm going to say if this is less than 10, then it's in size class 1. So the smallest size class. If it's less than 10, okay. I'm going to also write the second simplest equation here, and that's if this is greater than 100, it is going to be in my largest size class. I'm going to just count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to have 11 size classes. So that's the largest size class. Okay, those are the simplest ones to write. I've got a series of more complicated if statements now for the other 9. And the reason for this is if I'm going to categorize stems between, say, 10 and 20 centimeters, I have 2 conditions that I have to satisfy. So what I write here is another logical statement nested within the first one, and that's and. If and this is greater than 10 and less than 20, then I have to close the and statement, then it's a 2. Otherwise, it's an if statement. All right. So given how many of these I have to write, the most efficient thing to do here is to simply copy all of the parts that I want to work with. And you can do this if you work within this dialog box up here. It works as a kind of text editor. So what I did was I copied what I need to work with, and then I pasted it, and I'm just going to update all this. So I'm just going to increase everything, all my categories by 10 centimeters. And I'm going to update my index. Let's see, I'm in the 40s here now. This is kind of boring, but it's I don't actually do it this way anymore. I use a better indexing program. We may as well do this the entire way here. Where am I? I'm at 60. Oh, I forgot to do this. I'm at 6. I know this is boring, but you may as well do it. Doesn't make for great video watching, but if you're working along here, it can help you. Let me just make sure that I did that right. I did, and now I got the problem is I'm on top of the thing. Let's move that. 8. Oh, this is really fun, huh? This is just like, I know you're gonna spend your weekends just like, let's watch that video on how to write a massive if statement again. It was so much fun. Okay, we're almost there. I got the last one here, which is category 10, and that's 100 and then 90. And then the last thing I need to do here is that's the last of it. So I got to delete that if statement, and then I start to close all of these parentheses. And yeah, a lot can go wrong here, and we'll actually see if mine works. It says there's a problem. There's a problem. Not trying to write a formula. Okay, so I hit OK. There are so many nested if statements here, it can really create a lot of problems. And so in order to avoid having to write this again, I'm actually going to copy it, and I'm going to put it into a Word document. So I'm going to do this here. So I'm going to take it over here, and I'm going to hit that because I don't want to lose this. It's so annoying that I've had to do it. So now I have to get back over here to figure out what's gone wrong, and this is again pretty tedious. If and that seems to be correct, and this is the kind of not very fun part about this. You have to always figure out what it is that went wrong. And there's probably a missing. There's a missing parenthesis or something somewhere along the lines here, and I haven't been able to find it. So let's see here. I've got the logical test. If false, it should be 10, and it should work. Well, let's look at this again. Not trying to write a formula when the character is equal to Excel thinks it's a formula. Right. All right. Oh, so one thing that we can do here is to make sure that we're not going to end up with any problems is we can actually turn these categories into text. That might help. I'm going to try that real quick. Yeah, the parentheses give you text. Like I say, it can be helpful. Let's see if that solves the problem here. And again, what I'm going to do is if it doesn't, watch out. Don't hit the escape key right now because it'll erase all your work. And that's something that I've learned the hard way. And it's the reason that I've got all that equation over there on the copied into something else. And so, I should have a write in a final false statement, and I'm going to just do false. Write that and see if this works. It still doesn't like it. So what I'm going to do is copy this and then put it into this thing here, because again, I don't want to lose all that stuff that I've written, because what's happening here is Excel is not going to let me go. It's not going to let it go. It thinks I'm still within the logical test. Value if true, and this should be the value if false. Got the and here. So I've been able to escape from that. I've got the value if false, logical test, and then something is breaking down here. Something is breaking down right here. And what is it that I did that was incorrect? Because I can see that everything back here is working correctly, and it seems like I have too many. I've got too many. Parentheses. I got to get rid of some parentheses. I know it's not very exciting. This is when I started to copy and paste. This is exactly how things go with Excel and why it's annoying sometimes. But you can see that it's so typical. I have to go through here, delete all these things, these extra things. No wonder Excel got confused there. And add one more, and then I hit enter, and oh, finally, all right, it works. Okay, so then the last thing I'm going to do here is I can copy all these, and I've got a few problems. This one came up as a problem because it's exactly 90. It doesn't know what to do with that. This one is exactly 10. You can make your if statement you can make your if statement less than or equal to or greater than or equal to. And what I'm going to do here is I'm just going to type in, enter by hand, oh, excuse me, that is wrong. Enter by hand what the category should be here. I'm going to say that it's less than 90, or 90, greater than or equal to 90 would be the 10th category. Same would happen here with the 10. I look down here, I've got 20, that's going to be the 3rd category, and the 2nd category, so on and so forth. And it only happened, it's happened a couple of times here, then it's not that big of a deal. And then I'm going to save that because I don't want to lose my work.